All right, everybody. Mr. Bear here one last time for this particular Nearpod to talk about how the different letters within our absolute value function changes up the appearance of the original parent function and how we can maneuver some things. We've talked about the letter A and the letter H, so there's one last one to talk about, and that's going to be talking about the letter K and how that adjusts our graph. So we're taking a look here at the letter K. And we need to take a look at our functions here. We can see that our A value is the same for all of these. We can see that our H value is the same for all of these. A value would be -2. H value would be +6. And we're going to look at how the K value would adjust our graph if everything else was the same. So how does the K value adjust our graph? All right, for the letter A here, a problem I should say, we can see that our K is on the back end here. That's a +3. That's a +3 for K value. Not a lot of thinking on this one. Not a lot of thinking for these problems. It's exactly how it appears on the back end. And for B, we know that our K value would be -3. And for our C question over here, or our C function, I should say, our K is equal to 10. And then finally, for this D1, there's nothing behind the absolute value function. There's -2 and then the absolute value x minus 6, but there's nothing behind there. It's okay to assume, using the identity property, that if there's nothing behind that absolute value, you can go ahead if you really want to and add in a +0, and that wouldn't change anything at all. But it would have let us know maybe a little bit more visually that our K value here would be equal to 0. For each of these problems, the A value is -2. I'm not really concerned about that here. For each of these problems, the H value would be +6, so we'll use that information. And again, I'm going to go ahead and graph these so we can kind of visually see how it's going on here. So our A, we know the vertex for A would be the location 6, 3. So I got to be careful when I do this. I'm going over 6 for the x value, and then I'm going to go +3. So here is our vertex for the A, and sure, the graph would be going downwards because it's a negative A value, but we're not worried about the rest of the graph. We're just looking at how we're going to be able to adjust our pictures here. B, the point was 6, -3. Our K value here was -3. So I go over x is 6 and then down to -3 for that one. For C, our K value was 10. We had the same exact H value. So we had the point 6, 10. And here's 3, 6, 9, 10 would be right there. And then finally for D, we had nothing on the back end of that absolute value function. We threw a +0 on the back end just to kind of help us out. And that point value would be the point value 6, 0 for our vertex. So again, we can kind of see how we adjust things here. All of these vertexes have the same exact H value, but they have different K values. So if I have a positive K, what that's going to do to my graph is it's going to lift it upwards. So A had a K value of +3, and even higher than that was a K value of 10 for our function that was labeled C. For our functions that have a K value that is negative, that's going to drop us down and make us go a little bit lower on the graph. So we're going to move our graph down a little bit. Just like here with B, where we had the K value of -3, we went below where it would be located for a normal parent function y is equal to the absolute value of x. Finally, much like that parent function, there was a +0 on the back end of our D function. So that's going to stay on the x-axis. That didn't change the location. It didn't move up from the parent function, which would be located right here. And it wouldn't move down from the parent function. It just stays the same exact level. Now it moved to the right, certainly from the parent function, but not up, not down. It stayed on that x-axis. So plenty of information to gather from just looking at the functions and being able to pick out information. The same holds true for our k values, which control whether the graph is moving upwards or if the graph is going to be going down a little bit from the parent function.